polymers as a field is extremely exciting. There's a range of applications where polymers are used, anywhere from the smallest of sizes to very, very large sizes. So I got started with polymer science during my undergraduate degree, which was in chemical engineering. Essentially, when we started doing undergraduate research on fabricating or synthesizing different types of polymers. And this essential undergraduate experience really sort of highlighted the various applications of polymers for me. This undergraduate research experience essentially shaped what sort of graduate education and what kind of career I was going to have in the future. One area of research that we are very heavily involved with is on the development of these so-called superhydrophobic or superoleophobic materials. So superhydrophobic materials are essentially materials on which if you throw water, water just beads up and rolls right off. One of the places where all people in this area have found inspiration is from nature, where things like the lotus leaf are famous for having the superhydrophobic behavior. So plants' leaves, or like the lotus leaf or other leaves, get this behavior to essentially try and wash off any dirt that they get on their surface. So when it rains, if there's any dust or debris on the surface, water comes in and just completely cleans off the surface.
We've been working on multiple projects in this group, primarily to do with how we can tune the functionality of a surface using different polymeric materials. We try to coat the surfaces with different polymers plus nanoparticle composites so that the material is either hydrophilic, which means water-loving, or hydrophobic, which means water-hating, or oleophilic, which means oil-loving, or oleophobic, which means oil-hating. By tuning these functionalities, we try to address different applications, so on and so forth.
Awesome. Now, for us in the group, we've been very interested in trying to develop very energy-efficient solutions for separating out oil and water. Now, if you remember the big oil spill that happened in the Gulf, where there was tons and tons of oil that was spilled in the ocean, it was very, very hard to clean up that entire oil. And the key part is that this is all done under gravity. So essentially, you don't use any other external source of energy to separate these things out. And this is one of the first time that anyone's been able to separate out all sorts of oil-water mixtures by just using gravity, or a membrane that can separate out all these oil-water mixtures by just using gravity.
What we do is we make a solution of the required polymeric material and the nanoparticle blend, and we pretty much dip it inside the fabric. We dip it inside the solution, and I'm just going to let it sit there for a few minutes. You saw that, I mean, we just left it in there for about a minute or so. I'm going to take it out of there and let it dry. I'm going to put water on this fabric, and you can see how water droplets are just rolling off from the fabric. So you can see that oil droplets are also very easily rolling off from the surface.
A lot of these materials that we made are very, very exciting. So, for example, water separation membranes. We've been contacted by oil companies who want to actually take this material and scale it up and put it in put it for the separation of the oil-water emulsions that they form. Similarly, for the Icephobic coatings, in collaboration with the US Army, we're trying to develop coatings for airplanes that prevent the buildup of ice.
To take these materials and to see how we can solve real-world challenges and solve such a problem, which is so prevalent. I mean, oil-water separation, you need it pretty much everywhere, ranging from oil spills to wastewater treatment. Things like that is what really excites me and most of us working in this lab.
And it's very, very exciting for me to see how many of the things that we've developed on a very small scale, understanding the physics of them or understanding things very fundamentally, how they're scaled up and go into a range of applications, many applications that we hadn't even thought of before.